So, logarithms. Alright, I get it. Logarithms suck. However, they're actually very easy to do if you understand them. But let's face it, you don't.
Boy, if you don't...
You see, logarithms are a lot like exponents, but flipped. Logarithms and exponents are essentially the big sibling of algebraic equations. Where there's things like multiplication and division, logarithms and exponents are there to make them more complicated and advanced. But how exactly do you solve a logarithm? First, you need your base equation. In this case, it's log base 8 64. And now you need what's called a common logarithm. A common logarithm is any logarithmic equation with the base of 10. If the equation doesn't have a common logarithm, you need to use the change of base formula. The change of base formula works to change a logarithmic equation into a division problem to make it easier to digest. Many logarithms, like the one in the example, can be solved using the change of base formula. Let's take a moment and go back to the example. Using everything we've learned so far, we've deducted that it does not have a common logarithm, and that it needs to be converted into the change of base formula to be solved. Now that we've converted the logarithm to its most primitive form, it's very easy to be solved. All you need to do now is divide the numbers and solve the logarithm in the calculator. We will get to the calculator part in a bit, but for now, we need to learn about the other rules of logarithms. Let's start with the power property. The power property is where logarithms meet exponents, and while it may look absolutely horrifying, it's actually pretty simple. Logarithms with coefficients usually require the power property to be used in order to solve. To solve an equation using the power property, you have to switch the coefficient over to the argument of the logarithm as an exponent. For example, 5 log base 4 2. Using the power property, we could then convert this equation to log base 4 2 to the 5th. Then all you need to do is convert the exponent, in this case 2 to the 5th would equal 32, and then solve the logarithm using the change of base formula. Another rule of logarithms is the quotient property. The quotient property may sound and look like gibberish at first, but like the power property, it's quite simple. The quotient property is the conversion of subtraction to division. For example, log base 324 minus log base 38. This equation looks like you'd have to go through 7 levels of Tartarus just to solve it, but using the quotient property, we can convert it just to log base 3 3. The way we do this is by smashing the two arguments of the logarithms together to create a division problem. In this case, it'd be 24 divided by 8. And after that, all you have to do is follow the change of base property and solve the logarithm. The final, and the most basic rule of logarithms is the product property. The product property is just smashing together the two pieces of an addition logarithm into one logarithm with multiplication inside. For example, log base 4 7 plus log base 4 9. Using the product property, that would smash the two together and make it log base 4 7 times 9. Now all you need to do from here is solve the multiplication, use the change of base formula, and solve the logarithm in your calculator. For those of you who haven't crumbled to dust and blown away yet, you can check your logarithms by using the logarithm button on the calculator. All you need to do is press the log button located on the left side of the screen and choose your number after that. Note that the only logarithmic input you can make is a common logarithm, so you'll be using the change of base formula a lot. But after that, all you have to do is input your final logarithm, copy down the answer the calculator spits out, and you have finally solved the logarithm.